Okay, welcome back. Are you ready to run another scenario? In this scenario, we have a clogged condenser coil. Very common. This outdoor unit gets clogged from all kinds of things. Walmart bags are wonderful for blocking these. A lot of weeds around them, just any kind of obstruction. Let me flip this to temperature. Let's see. Okay. So we have 50 degrees on our suction line, and that's what the evaporator's changing state at. We have 60 degrees temperature, 50 degrees on the evaporator, 60 degrees on the suction line. That's 10 degrees superheat. We have change of state at 145, and subcooling is 140. So we only have 5 degrees of subcooling. So in a dirty coil, the air is not flowing through, the BTUs are not being dispersed out of the system. So this temperature is not coming down as much as it should. We just can't get the BTUs out of there. Very, very low subcooling. Let's see what kind of temperature we have. I imagine this is going to be 140 on the compressor, not the compressor, the condenser outlet. Yep, 140. And in the house here, our supply is 75 degrees, so we cannot cool down the house. It's going to sit at 85. Take a look at your condenser. You can see it's clogged, so you're going to want to clean that condenser. And our delta T, we got 75 there. We have 85 degrees indoors, so we have a 10 degree delta T. Let's go ahead and do the repair. We have there's our problem. Just going back to it, poor condenser airflow. So the airflow would have been weak coming out of the condenser. And it's saying we could clean the condenser coil, we could remove the restriction, and we could check the fan blades for the proper position. Sometimes fan blades get mounted backwards, sometimes they get mounted too low or too high in the condenser unit. That will all have an effect, and it will be the same effect as a dirty coil. Let's test the repair. Measure head and suction pressures. This problem causes very high head pressure depending on the extent of the blockage, and slightly high suction pressure. Excessive blockage or high ambient temperature can cause high pressure switch or the compressor overload to open. In coil conditions, inspect your simulator. Let's do the repair. And now the system starts to stabilize in pressures, and the indoor temperature should be coming down. Our supply is blowing much colder now. Instead of 75 degrees, it's coming out at 68. We have a pretty strong delta T going on, and that's because it's under heat overload. It's heat load. It's a lot of heat in the house. It's got to remove all the heat, so it's going to have a higher delta T until it stabilizes. Until this comes down, we can speed up the time. We can watch the indoor temperature start to drop. And as the time passes, that heat will get removed out of the house and sent outside. And that'll satisfy the thermostat. The system will then cut off and run normally. So I can lock it. And we can stay running that way if I lock the temperature. And we can see our gauge set now is showing 40 degrees evaporation and 120 degrees condensing. We have 56 blowing out of the supply. Suction line is at 46 degrees, which is about 6 degrees of superheat. And our liquid line is at 105, so we got about 15 degrees of subcooling. Everything is looking pretty normal again. And that is the simulation of a clogged condenser. We're going to get into the electrical side on this, just not yet. Right now I'm running through the mechanical faults. And that concludes that one.